都可以，不然就就不用多久了。一辆，然后还是这样子。今天这条也是就跑这条球。我们类似丘比特嘛，类似在进行之前啊，教书有。
Okay, good afternoon, friends. Welcome back to our matrix course. Today we'll be doing revision for the final exam. Okay, let's get started. So we'll be practicing some of the questions which are very similar to the structures of our final exam. So I think you'll be able to expect what will actually come out in the final exam, right? And you will also need to prepare the A4 cheat sheet. I think some students ask about the open book exam, right? Open books means that you are allowed to bring in one A4 cheat sheet, and only one A4 cheat sheet. But you have to be physically printed, right? Because it is a final exam, right? So it is managed directly by the exam unit, right? So we have to follow the regulations strictly set by the final exam unit. Let's get started. I think for friends joining online, are you able to hear me and see my share screen from your side? If yes, please let me know in the chat. I'm asking those joining online. Okay, great. Okay, let's get started. Okay, we'll start with the first questions. My friends joining online, if you have any questions, right, you can always let us know through the chat. Okay, we'll look at the first question. Okay, let's say, right, you are given a function f, right, where each of these x1, x2, right, is a vector. And we have k of them in total. And we are also given an additional constraint here. Right, we are required to satisfy that, right, the norm square of each of these vectors to be 1. X1 to x2, x1, x2 to xk bar, right, are mutually orthogonal. Right, what is the name of this particular function? Do you still remember the name for this particular function? When we look at this, we know that this is a quadratic function. But how about this? And this is the norm constraint. Right? So this is a norm constraint quadratic function. Okay, let's say, right, in the exam, right, or right, just let's say, right, the A is given to you. I'm just writing random values here. And let's say 0 0.5, 0 0.2, 0 0.1, 0 0.9. Okay, sorry, I think this A have to be symmetric. So this A have to be symmetric, right? Based on our understanding of a quadratic function. So I cannot simply write random values here, right? So I have to satisfy, right, the characteristic of a quadratic function. Let's say this is 0 0.1. Right, since the matrix is symmetric, I can simply copy, right, the values from the other sides of the off-diagonal entries. Okay, let's say A is given to us. Okay, and you are also given the eigenvalues and eigenvectors of this matrix A. And let's say because of this matrix A being symmetric, right, we will be able to decompose it into, right, a product of three singular matrices, and based on what we learned from eigen decomposition. Okay, let's say both V and delta is given to you. Okay, let's say, right, this is our V. And you are also given the eigenvalues. Let's say the eigenvalues. And let's say we have four eigenvalues here. I will just write out random numbers here. Or we can just, okay, let's just call it E1 to E4. Right, and E1 and E4 has been sorted, right, in a non-increasing order. Right, so it means that E1 is larger than E2, right, E2 is larger than E3, right, E3 is larger than E4. Okay, so the question here, right, is that, let's say, for k equals to 3, right, find x1 bar, x2 bar, and x3 bar, right, such that f, right, is maximum. Right, so we want to maximize, right, this particular f. Right, we want to maximize this particular f by finding, right, our x1 bar, x2 bar, and x3 bar. So how do we approach, right, this particular questions? This is actually from lecture 6. And then let me bring out the lecture slide from lecture 6. So if you go to lectures, right, slide number 8, right, the solution is actually provided by in this final paragraph. Alright, so the solution is actually available directly from the item vectors in the Let us look back at our questions again and try to apply, right, what we learned earlier, right, to solve this particular problem. Okay, so since right k equals to 3, right, and we are looking for common. And we want to maximize this f. Right, so the solution, right, is actually available from the top 3 eigenvectors with the largest eigenvalue. Right, let us try to write the solution out explicitly. So our x1 bar actually equals to the top eigenvectors, right, or the eigenvectors with the largest eigenvalues, and based on what the solution, right, that we discussed in our lecture slide. So what will be the solution here? And which particular eigenvectors has the largest eigenvalue? E1, right? E1 is the largest. So the corresponding yeah, great. Right. So the corresponding eigenvectors will be A1, A2, and to A4. Right. Similarly, we will be able to obtain our solution for x2 bar, right, which is B1 to B4. Right. And for x3 bar, it is simply C1 to C4. And we simply need to copy them from the eigenvectors. So I think in this particular questions here in the final exam, you simply need to copy, right, the host value, right, to the solution. Right, how about the values f? What is the maximum value for this f? And this is what we learned. We do not really need to substitute, right, this back to the equation that we had earlier. We do not really substitute all these x1, x2, and x3, right, to back in the original equation. Actually, the solution is already available in the eigenvalues. Right, so f actually equals to E1 plus E2 plus E3. Right, the sum of the top 3 eigenvalues. Let's say we modify this question slightly. Okay, so instead of having k equals to 3, let's say we reduce this to 2. And we try to solve the minimization problem. We do not have x3 anymore since we reduce k equals to 2. So what we are looking for now, right, is x1 bar and x2 bar, right? So we do not need x3 bar now. So what will be our solution for x1 bar? D1 to D4, right? Great. How about x2 bar? C1 to C4. Right, great. How about the objective function value f? Great. Right, so you see, you'll be able to see how powerful is this eigen decomposition. Right, is when it comes to optimizing, right, quadratic function and the non-constant. Right, so after eigen decomposition, right, we have our solution, right, directly available, right, from the eigenvectors and eigenvalues. Okay, let's look at another question. So the second question is actually from our lecture slide, right, from lecture 12. Right, I think previously we do not have time to actually go through the derivation, right, or compute the derivative, right, but let's do it together in this session. Right, if you still remember from our lecture slide, right, we have this objective function j. Let's say, right, you are given an initial value for W1 and W2, very similar to the assignment 4, right, that you are working on now. Let's say W1 is initialized to be 1, W2 is initialized to be 2. You are asked to perform gradient descent, and Newton update, based on what we have done. Very similar to what you are trying to solve in your assignment. Just that during the final exam, you have to write them down explicitly in your answer booklet. And then let's try to practice how to do it by hand. Okay, let's say we start by looking at gradient descent. So to actually perform gradient descent, what will be the first step? What do we need to perform gradient? Now, Rajay, great. Great. We need to compute gradients. Okay, let's try to compute this Nabla J together. Nabla J is the partial derivative of J with respect to W1 and partial derivative of J with respect to W2. To W1 plus sine plus sine W1 plus W2. How about the second entry? To W2 sine. Okay, great. Great. So this is what is required for gradient descent. Let's say if you want to perform Newton update, what is the additional terms that we need to compute? Haitian. Okay, so we'll be able to compute the Haitian. Okay, let's do it together. Anyway, this is the same as this. There's a missing delta. Okay, let's try to compute this together. What will be the first entry? 2 plus cosine W1 plus W2. And how about the other diagonal entry? The same. Okay. How about the off-diagonal entries? Since this matrix is the matrix, so it will be the same. So usually in the final exam, this W1 and W2 is assumed to be radian. So when you key in this value into your calculator, please use radian. Don't use degree. Use radian. Okay, in the final exam. Let's say if something involves these sines and cosines terms, I try to use gradient when you key in your values into your scientific calculator. And that's very important. You have to practice it before the exam. We will not be using degree. We will be using gradient. Okay, let's try to perform, let's say, gradient descent, for 2 steps. Okay, so we will be able to somehow visualize, somehow we turn this calculation into something mechanical, so that you will be able to do it very fast in the final exam. Let's say we start with W0 bar, which is our initial value for that we use to initialize W1 and W2. And then we perform gradient descent for 2 steps. So we started with a values of 1, 1 at the beginning. So because W1 and W2 is initialized to be 1, 1 at the beginning. Okay, sorry, 1, 2. Okay, sorry. 1, 2 at the beginning. Very good observation. Okay, so and we want to perform gradient descent with number G of W0. To actually perform the second gradient descent update, we actually require number J from W1. Okay, so what we really need to do, is to substitute this 1, 1. 1, 2. 1, 2 back to this. You simply throw in the values of W1 equals to 1 and W2 equals to 2, the expression. Okay, let's say after you substitute the values to the expression, what you get is let's say AB. So this is what you obtain from the scientific calculator. But don't write AB in the exam script. You have to write out explicitly the numerical value. Okay. So how do we perform gradient descent with this? Yeah, we need running rate also. So usually in the final exam, let's say the running rate given to you, let's say is 0.205. Our lucky number for this course. Okay, so we will be able to compute our W1 bar, okay, using the gradient descent update rule. Minus running rate times number J. So we have everything required here. W0 is this. So we have W0, we have the running rate, we have this number J. We will be able to compute our W1 bar. And let's say after you throw in the values into your scientific calculator, you obtain CD. We'll be able to perform gradient descent for another step. So we have CD here. I will be able to compute our W2 bar based on W1 bar minus alpha Lagrange J of W1. So we have everything here. We have W1. We have the learning rate. We have Lagrange J. Okay, let's say this is EF. We'll be able to substitute them into our expression. Eventually, let's say we obtain the solution G and F. And so in the exam, we have to write out everything, numerical values for everything, because marks will be given to the final answers also. So it is important that you show. Of course, if you write it in this way, you will get partial marks also. But try to get full marks, since we have been practicing this a few times, mainly, previously it was done in your assignments and tutorial. In the exam, somehow you have to be handwritten. Yeah, I believe it's not difficult. Okay, let's say we want to perform Newton's update now. Right, to perform Newton's update, we will be able to use the same visualizations. And let's say if you are asked to perform Newton's update for 2 steps. Okay, so we will be computing Lagrange of W0 bar and also Hessian, right, at W0 bar. Right, similarly, right, to perform the second Newton update steps, right, we will require the Lagrange, right, at W1 bar, right, and also the Hessian, right, at W1 bar. Okay, so to actually compute them, right, we simply need to substitute, right, the value. And let's say we simply substitute this the equation, right, for Lagrange and H, we will be able to obtain, right, let's say, right, the value, and let's say if this is input, right, this is C, D, E, F. Okay, so we are just simply substituting, right, W1 and W2, right, into the expression, right, that we computed earlier. Okay, so after that, we will be able to compute the value for W1, right, based on Newton update. Right, minus, right, H inverse Lagrange. Right, this is exactly what we computed earlier, right? We simply need to substitute it, right, into the expression value. Right, we have everything, right? We have W0 bar, right? We have H, right? We have Lagrange. Right, so we will be able to compute the updated value, right, for W bar. Okay, let's say, right, after the update, the solution that we obtain, right, is GH. Right, so we have GH, right, for W1 bar. So GH. Okay, so after that, we will be able to perform Newton update for the second time. Right, and eventually obtain our final solution. And let's correlate IG. Okay, so pay attention to this, right? So this J of W0 bar and J of W1 bar, right? They are not equals to each other, right? So you have to be recomputed, right? Every time, right? At every step. Right, so please pay attention that these two values, right, numerical value, right, will not be the same. Right, so you have to be recomputed. Okay, so let's say, right, if you want to compute this Lagrange of W1 bar, right, so what are the value that should be substituted, right, into the expression? Right, let's say if you are looking at Lagrange, right, what is our W1? G, right? So we will substitute this W1 with G, right, W2 with H, right? And it was 1 and 2 in the second step. And so pay attention to this, right? So this Lagrange and Hessian have to be recomputed, right, at every step. Okay, so do you have any question? right, based on what we have discussed so far. And so we just discussed how to optimize, right, a function given to us, right, with gradient descent, right, and Newton's update, Newton method. So not sure why it keep popping up. Do you have any questions so far? No question. Then we will proceed to the next question. I think the most important thing you have to practice, right, for this question, right, is how to utilize your scientific calculator. Right, this is something that you have to practice a few times before the exam. Okay, the next question is on regression. Okay, let's say you are given a set of data points. And you are asked to build a linear regression model, right, to learn the relationship between X and Y. It is equivalent to designing a perceptron, right, with 3 inputs. Right, we have additional bias term. Okay, so let's say, right, you are asked to come up with, right, the problem formulation. Right, how do you come out, design a machine learning algorithm to solve this problem? Right, you have to write out every step. Right, for example, you will have to write out, right, the objective function designed by you. Right, what is your objective function, J? Right, so let's say you want to define an objective function, right, J of W bar, right, because eventually you are looking for this W bar. So you have to write out, right, the objective function explicitly, right? So this is something that we have learned, right, from our lecture slide. And anyway, I will just write them out explicitly here. And so this is what we learned from the lecture. So we need to define, right, what is our D. Right, so what is our D here? And then columns of 1, right? So to actually build our data matrix D, right, we will copy from X1 bar and X2 bar, and we append it, right, with columns of 1. Right, so of course, right, in final exam, you write down the value explicit. Value explicit. Okay, so after that, right, you will be able, I mean, based on this, right, based on the matrix calculus, right, or even Newton's method that you have learned, right, you know how to compute the closed-form solution, right, for this particular expression, right, because we know that, right, W bar, right, is actually equals to D transpose D plus lambda I, right, inverse D transpose. So to actually compute this term, we have defined by us. This, of course, the lambda will be given, right? Let's use in the question, and let's say lambda equals to 205. So B is already available, so that one is our Wi-Fi. The third column, okay, the third column is our Wi-Fi. Column vectors. Okay, so what will be the next challenge? The ability to throw this into your calculator. So are you able to foresee any challenge here? So when you throw this into calculator, I think that there are a few tricks, right, and tips that you can use. But 3.4 plus 4 times 4. Yes, yes. So somehow the metric is actually 5 by 3 by, sorry, 5 by 3. Yeah. So somehow we need to use something here. At least one thing that I will be discussing it very soon. I think the other issue that we need to ask ourselves, right, that whether we compare the products between the first two terms first or the second first. It makes a lot of difference. Although mathematically they are equivalent. So actually, your answer and the length of your answer can be quite different. The length of the answer that you have to write down. And we compare the products between the first two terms first, or the last two terms first. Do we do this first, right, or this? First two. Why? Yeah. Maybe, right, if your scientific calculator allow you to key all of them at once, so maybe you can do them together. But if you want to solve, to calculate this term by parts, right, you have to compute the second, I think the products between the second and third first. So if you are solving this particular questions, right, with handwritten, right, approach, we will be computing the products between these two. And this is, if you look at the products between the first two terms, right, we are computing products between matrix. Right, but if you look at the second and the third term, actually we are computing the products between matrix and vector. Right, this is between matrix. And the products between two matrices will give us another matrix. And the products between matrix and vectors will give us a vector. So we should be computing this part first. Yeah. And then we will use this for vector. And so the products between the second and third term, right, we will reduce this to a vector. So the only challenge, right, that we left with, right, is in transposing. So how do we show this value into our scientific calculator? So maybe we'll write them out explicitly. So let's say, like, we copy this thing. Right here. 6, 5, 4, 3, 7, 1, 6, 2. Right, with columns of 1. And for the D transpose, I will simply need to compute the transpose of it. So how do we compute this with our scientific calculator? Huh? By hands? I think we want to maximize the use of scientific calculator.
But maybe plus 4 times 4 at 5.
Here. So we need to apply that here.
Or we do it.
You think about the outer products view of matrix multiplication. Still remember the third view of matrix multiplication. And we learn from matrix. Here, right. Somehow we decompose the matrix into the sum of rank 1 matrices. Right, for example, 171. 171. Plus the second. Hold on. Since the third view of matrix multiplication, right, tell us how to decompose them, but we know how to put them back. So let's say if we put the first 3 terms back to a matrix, right, so we will be getting right, multiply with this, right, the first 3 at 1, 7, 6, 5, 1. Right, so if you look at it carefully, right, we are simply copying this. Right, for this, the second matrix, we are copying the top parts right, from the second matrix. Right, so we are trying to combine the first 3 components and back matrix multiplication form, right, based on the views of matrix multiplication. Right, and we will be able to do so right for the remaining one. Now you can throw this into your scientific calculator. And you get this 3 by 3. This is actually the transpose of this. Similarly, this is the transpose of it. So if you know how to make use of the variable right, in your scientific calculator, let's say you'll be able to define this as matrix A. Right, this is simply matrix A transpose. Matrix A transpose. Right, so this is, let's say this is B, right? This is B transpose. Right, so you can define the first matrix using a variable in your scientific calculator, you will be able to simplify the calculation. And in your calculator, after you key the values from matrix A and B, you will be able to compute matrix A times matrix A transpose. So you will save you a lot of time doing the exam. So this is what we learned from lecture 1, right? So even something that we learned from lecture 1 turned out to be very useful, right, in our final exam. So I think please try to practice this. I think so that you'll be able to use like a lesser amount of time, right, during the final exam. I think this is the main calculations questions that you will encounter, right? I think I would say, right, the most important one, right? It will definitely appear in the final exam. Okay. Of course, there are others, right? But these three will definitely appear, right, in the exam. Okay, so I think for the other parts, right, you can focus on concepts and applications, right, of what we learned. Right, for example, I think we learn actually a lot of important, right, concepts. Right? For example, eigen decomposition, SVD. Right, in our previous session, we discussed about adder grade, IMS probe, and Adam. Right, some of the applications, right, can be, right, let's say dimensionality reduction, right, or even, right, we also learn about recommender system. And let's say if you are asked to build a recommender system, right, for a company, right, you are given a scenario, right, how to design, right, a system for the company. Right, or it can be regression also, right? Let's say you are given a scenario, right, a real world problem, right, that, right, your CEO from the company might give it to you, right, and you're asked to come up with, right, a technical plan, right, to solve the problem for the company. And that will be more on application. But of course, right, there will be questions on, right, some importance, right, matrix properties also. I think the other part, right, is on this, right? So you have to practice how to do matrix calculus also. And let's say you are given an arbitrary objective function, like how do we compute number J of it? And that is the matrix calculus part. And let's say you are given an objective function in matrix multiplication form, and you are asked to perform, right, or compute number J. Let's say you are asked to compute number J of this particular objective. Right, so how do you utilize table 1 and 2, right, to compute averaging? Exactly, right. For this particular objective function is something that we have practiced during lecture. And so you might be given an particular objective function and you're asked to perform calculate the derivative based on table 1 and 2. Table 1 and 2, right, for matrix calculus. Similar in matrix calculus part, and we have table 1 and 2. One for scalar with respect to a vector, and the second one is a vector with respect to another vector. So, much more like the same. Yeah, after this session, I will be sharing the working example for this particularly transporting upload it to the because you compare your calculation with what we obtain. Okay, I think that's all we want to revise, right, for the final exam. Right, do you have any questions, based on what we discussed so far? Anyway, I recorded this session, right? If you want to look at it, right, you'll be able to find it from MS Teams. Do you have any questions? Any additional questions that you would like to ask? During the final exam, right, it's important that you bring your A4 cheat sheet, right, and your scientific calculator. There are 3 big questions. Total. Each of them come with a few sub questions.
分主要是分或多少17%
Around 70% is calculation. The other 30% is more on concept and research.
Right. 概念相似，背好好抄一下，抄一下。最好懂，不然的话到时候找不到。是的，最好懂，不然到时候找找不到。其实
I think it is very important that you practice how to use your scientific calculator. That is one of the most important thing for this exam. If you don't bring your scientific calculator, right, we will know that you are giving up, right? Every calculation question will require scientific calculator. Right, so I will not, I think in the final exam, right, this value will not be integer. Actually, it's a numerical value. The real world is not right? So it will not be integer during the final exam. All right, for friends joining online, right, do you have any questions? So I will be releasing, right, the consultation hours, right, for final exam, right? If you need extra consultation hours, right, you can come during that particular session. So I will release it on Moodle. Right. So if you don't have other questions, we'll be able to end our session here. All the best to your final exam. And please remember that the deadline for our assignment is by the end of tomorrow. The exam the materials that are covered in the exam, right, is from lecture 6 onwards, 6 to 12. So it includes 6, although our quiz, right, is from 1 to 6, but for our final exam, it starts from 6. Okay. So lecture 6 is included in the final exam, 6 to 12. Any other questions?
Let me write the 0.205 in the slide deck there. There's a photo.
So if you do not have other questions, we'll end our session here. All the best. Your final. We'll see each other again in the final exam.
Yeah.
All the best.
Bye.